Now, since we have the the question given is this, and I was able to show that this expression is equivalent to minus 1 of x plus 3 raised to the power of minus 1, then plus 1 of x plus 2 raised to the power of minus 1. Now, let's start by finding the derivative for what? For y. So the first derivative for y is y prime equals, so I can differentiate this separately. And for you to differentiate this is very direct. For this term, if I want to differentiate this term, then that means I already have a negative 1 here. So I'm only considering the derivative for this one. So when I differentiate this expression here with respect to x, this power serve as the coefficient times, I already have times here, this minus 1 come down, then times, I need to multiply it by the derivative for this x plus 3. So the derivative for this x plus 3 is 1, right? Then times, repeat everything back, which is x plus 3 raised to the power minus 1, but you must subtract 1. So I think you should be familiar with this. That's how to differentiate. And then the next one here is, I already have 1 here, dot. Now I want to consider the derivative for this expression here. The same thing applicable. Minus 1 will come down, times differentiate what you have inside the bracket, which is 1, times, then repeat everything back, which is x plus 2 minus 1. You must subtract another minus 1. So that's how it works. Hence, the first derivative for this expression is minus 1, open a bracket, another minus 1 here, with x plus 3 raised to the power of minus 2, plus 1 here, minus 1 inside, x plus 2 minus 2. So hence, when you open up the bracket, negative 1 times negative 1 will give you positive 1. So I end up having just 1 of x plus 3 raised to the power of negative 2 plus 1 of, okay, I have positive 1 here, plus times minus, I have a negative 1 here, of x plus 2 raised to the power of minus 2. So that's how it works. Now, since we already have the first derivative to be 1 of x plus 3 minus 2, negative of 1 of x plus 2 raised to the power of minus 2, then what would be the second derivative? So we need to follow the same process of what I've actually done before. So then my y2, which is the second derivative, will be equals to the same process. I have to differentiate this term. And I said this one is there times. So I need to differentiate this thing that I have here. So minus 2 comes down, times differentiate total outside the bracket, times repeat everything back, minus 2, then you must subtract 1. So that's how it works. So then that ends the answer for that. Then for the second term, which is minus 1 outside. So I need to differentiate this x plus 2 is to the power of minus 2. Minus 2 comes down, times differentiate what you have inside the bracket, which is 1. Repeat everything back, which is x plus 2. Then subtract 1 up there. That is minus 2 minus 1, that is minus 3. So let me write it out first. Hence, I have my second derivative to be equals to minus 2 times 1, that's minus 2. So, and I end up having x plus 3 raised to the power of minus 3, right? Then I have a negative here, and I have a negative sign here. That gives a positive sign of what? 2 of x plus 2 raised to the power of negative 3. So, trivially, this is for second derivative. This is for first derivative. What I actually notice is that I have one positive one, I have negative one. Now for the second one, for the second derivative, I have negative 2, positive 2. There's a change in the signs. Okay, what happens to the third derivative? I'll still try to show the workings. So, but not in this. I've actually explained the basics. Now I'll just go straight to the derivative for it. So now here in this case, I have minus 3. It's going to minus 3 multiply this minus 2, giving us just 6. Differentiate what you have inside the bracket, which is 1. Repeat everything back, which is x plus 3. Subtract 1, that's minus 4. Do you understand that? So that's how it works. Then the next thing here is minus 3 times positive 2. Minus 3 comes down when you differentiate. So that gives a negative 6. Then differentiate total outside the bracket, we have 1. Repeat everything back, which is x plus 2 raised to the power minus 3. When you subtract 1, you still have negative 4. So this gives the third derivative. Now it doesn't end there. What is the fourth derivative? So that I will be able to generalize. I need like first 4. Sometimes by the time you generate the first derivative, second derivative, and third derivative, and you generalize, you notice that the result you get, by the time you try for the next term, the generalized term you actually formed will not give you exactly, will not give you an exact answer for y4. So it is advisable you try to work with the first derivative, second derivative, third and fourth before you generalize. Sometimes you try the fifth derivative before you what? Before you generalize. So that's how it works. Now the next thing to do now here is that we have to differentiate this third derivative, giving us minus 24, right? Minus 4 times 6, that's minus 24. Then x plus 3 raised to the power of, subtract 1, that's minus 5. Again, minus 4 times minus 6, that's plus 24. Then I have x plus 2, all raised to the power of what? Negative 5. So this gives the result for the fourth derivative. And by the time we generalize, if you keep on doing this, you know what to get. So we need to find the nth derivative, which is what? Up to y raised to the power of what? N10. Suppose you want to find 100th derivative. So what will be the answer without even going through all these steps one by one before you get to know? That's very, very long. So we need to find the nth derivative. So what I'm going to do now is I want to write everything out. The first derivative, the second one, the third one, the fourth one, then I generalize. So that's the only thing we have left to do. So for the first derivative, we have the first derivative. The result is 1 of x plus 3 raised to the power of minus 2. Then with a negative 1 of x plus 2 raised to the power of 2. The second derivative is minus 2, and I have x plus 3 here. I have a negative 3 plus 2 x plus 2 raised to the power of minus 3. So by the time we write everything out, we have this. So we need to generalize. But before we go ahead and generalize in this case, I would have preferred us to factorize. We know 1 is common here, 2 is common here, 6 is common here. So we'll be able to generalize. Now, here in this case, I have the first derivative to be equals to just 1 outside. There's a reason why I'm actually writing 1 since morning. So there's a reason for that. 1 is outside there. Then I have x plus 3 minus 2. Negative of, I have x plus 2 here. Then um I have 2 up here, right? Negative 2 rather, is a minus 2. So then here in this case, which is the second derivative, for us to have the same thing inside this bracket, I would prefer we factor out minus 2. So here in this case, minus 2 is common. Then we end up having a positive sign here, which is absolutely correct. Then if this is minus, automatically speaking, this should be minus. So that we'll be able to say that when minus multiply minus, we end up having this positive sign that we have here. So it's correct. So then we have just x plus 2 raised to the power of minus 3. So you see, we have the same sign inside inside the bracket and the same thing. So it will be very, very easier for you to generalize in this case. Now the third one is 6 is common. Then I will end up having x plus 3 raised to the power of minus 4. Then negative of what? X plus 2 raised to the power of minus 4. Next thing is the fourth derivative. The fourth derivative is negative 24 is common. Then I will end up having x plus 3 raised to the power of negative 5 minus and minus is plus, x plus 2 raised to the power of minus 5. So it's making sense. So from this from this case now, I noticed that I have a positive sign, negative sign, positive sign, negative sign. So that shows, okay, I want to generalize up to nth derivative. And this implies that since I have a positive sign here, negative sign here, positive sign here, and negative sign here, a sign changes when you have one. That should be, suppose we have a negative one inside there, and I raise it to the power of n. If n is 1, if n is 1, then that's not correct. I'll have minus 1 raised to the power of 1. So that does not, this is the first one, this is the second term, third term, fourth term. So if I put n here, that's not correct. What if I increase it by 1? By saying if I have n, let's say plus 1. So if I have the first term, which is y1, when n is 1, you see, when n is 1, 1 plus 1, that is 2. So minus 1 all raised to the power of 2, that will give me positive 1. That is correct. So what if I end up this the generalized term I'm trying to put here is for only the sign. I've not considered 1, 2, 6, and 24. No. I'm only considering the signs. I have plus 1, minus 1. So let's try for when n is 2. When n is 2, I have 2 plus 1, that is 3. So what is minus 1 raised to the power of 3? That is minus 1. Invisible minus 1. So this is satisfied. Now the problem we have now is that we need to find the generalized form of 1, 2, 6, 24. Trivially speaking, this 1, 2, 6, and 24, I noticed that it actually gives 0 factorial, which is 1, 1 factorial, 2 factorial, which is 2. This one is 1. When n is 1, I have, okay, sorry, let me use 1. 1 factorial will give me 1. 2 factorial will give me this 2. Trivially, I can easily say that 3 factorial will give me this 6. You see? So, and then 4 factorial will give me this 4. So, hence, when I have n to be 1, when I have n to be 2, when I have n to be 3. So, that means if I have 1, 2, 6, 24, I can easily tell you that we end up having just n factorial. N factorial. Do you agree with that? That is, when n, let's say when n is 4. When n is 5, I have minus 1 raised to the power of 4 plus 1, that is 5. If it is odd, you have a negative sign, which is correct. And then when n is what? 4. 4 factorial, that is 24. So it's satisfied. So when you find the generalized term for 1, 2, 6, and 24, the generalized term is n factorial. So what do you have left? A bracket open. I have x plus 3 fixed for everything. So x plus 3 is common to all the expression I have inside. And then there is an increase. Okay, I have a negative sign outside there. What if I decide to, okay, let's say we have a negative sign here, and you open a bracket. When I have 1, I have 2. When I have 2, I have 3. That means there's an increase in the n, in the nth term. When I have 1, I have 2. That means when I have 1 here, when n is 1, I have 1 plus 1, that is 2. So times minus, I have the what? Negative sign. So do you understand that? So with a negative sign of what? X plus 2. The same thing. When I have minus 2 here, then this should be n plus minus of n plus 1 also. So this gives the nth derivative for the question given to us. So thanks for watching. Then the next question, for the next video, I'll try to explain how to find the nth derivative for this second question, which is y equals to exponential raised to the power of ax, then times sine of ax plus b. Thank you very much. Thanks for watching. Please remember to subscribe. Thank you.